Good morning, grade 7. We are now in the continuation.
Morning.
Yes, good morning. The scientific method. Okay. I think in the SIP. We will now move to the SIP. Scientific investigation. Okay. Scientific investigatory project. You know what? I had a lot of memories with science investigator project or scientific investigation because when I was still in your age, I tend to investigate of the things that I find it very interesting, especially with science. Okay, I even have my first dissection. Take note, first dissection when I was still in first year high school. That is actually grade 7 in our curriculum now. So that was my first dissection. I dissected a frog, and um, I had seen also the patterns of nature. Okay, the natural way on the arrangement of internal organs. Those are the patterns of nature. It's the natural way. So if you're going to look at also, what I had discovered was the patterns of the internal organs of frog and humans are actually similar. They're actually similar, even the muscles. So I was amazed. That was the time that I I actually got um really in love with.
Ano sa mo yung charger dito no?
Dili, dana na. Dana na sa CCTV. Ay, sorry.
Hi Kaiser, good morning.
Good morning, teacher.
Right. So let's move now to scientific investigation. Sure, was it hard? To tell you honestly, you're the one making it hard because science is really easy. Those are concepts. Okay. The Science Investigator Project, or SIP, employs a scientific method to find answers to the problem. In the actual practice, conducting an investigatory project involves several phases. So, okay, phase A. This is the proposal. So I'm sorry for that. Let's continue.
Okay.
Let me share my screen again. It started at phase A, or proposal. I actually did this one before, and for me it's really fun. Okay, the proposal is a written plan on how the investigation will be done. This is your plan. Like, I want to investigate on the plant's movement. This is actually the things that I want to be done. Okay. Okay. The verbs used are in future tense since they are yet to be executed. I will, right? It consists of the following. 1, problem. Okay. To define the focus of your problem, ask the following questions. What topic interests me? Okay. What is it all about? The topic that interests me most. Okay. What do I want to know? So these are the questions that will define your focus in the problem. Okay. Statement of the problem. This is the statement of the problem. Rationale. Okay. This gives the background of the study and the reason why you want to pursue your topic of choice. It answers the following question. How did I arrive at that problem, or the one that I've been choose, or I had choose? Why did I choose this topic? For what purpose? So this is the rationale, okay, of your science investigatory project. Okay, review of related literature. This is a portion that contains the findings of other investigation related to your study, because you'll be searching, diba? You'll be searching for a resource on how to conduct this study. So this is now the review of related literature. A comprehensive review of related literature entails extensive research using different sources and types of sources. One of the good source there is your internet, okay, your net, your websites. But make sure that you reviewed a good um good work or good source, simply because not all that is actually in the internet are true. Some of them are just created out of their minds. So you need to review it over and over. Hypothesis, okay? This is your working theory or prediction to the question, okay? To the questions that you have asked in the first, correct? You have your statement of the problem. Now you tend to answer your statement of the problem. This is now your hypothesis, okay? If and the, okay? If the if this is the case, then this is the result. So this is now the hypothesis, okay? If I will put like for example this one, if I will put um the 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 plant inside the box, then it will eventually die. So it is actually hypothesis. Hypothetically, you're stating that the plant will die if you put it inside the box. Here comes experimental procedure. Then you need to make an experiment. Okay, please. I'll just handle this one for a while. Huh?
EA service provider.
Right, shall we continue? I'm sorry for answering a phone call, Right? So let's continue with the experimental procedure. So this part includes the materials and procedure that will be employed in the experiment. So you will now try to prove if your hypothesis is true. Okay? Because we cannot actually science uh, a body or a body that comprised with facts. Okay? If it doesn't contain any facts or explanation, therefore it is not actually a science. It is a pseudoscience, just like your superstitious beliefs. There's no scientific explanations there. So if there is a scientific explanation, therefore it is a body of science. It is part of science, right? Okay. These are the question. What materials and equipment do I need for the experiment to be done? Okay. Are the materials available? That is the availability of materials. What else? What steps I follow or should I follow to test my hypothesis? Should I follow the scientific method? Should I follow the discovery approach? So these are the ways, right? How do I collect or how will I collect my data? Okay, it is, should I collect it through quantitative or to qualitative? Quantitative means to say it's what? It is actually gathered through what? If it is quantitative data, through tools. Okay, measuring tools and all of those. Those are quantitative data. How about qualitative data? Qualitative data is gathered through the senses. Okay, all your senses. So that is actually under qualitative data. How will I organize my data? Okay.
Isn't that like the method of observation?
Yes,
The
those the methods of
qualitative.
observation. Diba, when you observe, you tend to write what have you seen, what have you feel, what have you tasted. Those
Or
are
remember.
qualitative data. Okay. If it is quantitative, you are actually talking about the measurements. Like for example, I have 5 ml of water and a 1.5 ml of sodium hydroxide. I mix the sodium hydroxide with water. What will happen? So those are just few. Okay. Those are under quantitative data because you're gathering the data with the use of your tools or your laboratory apparatus. Okay, let's move forward with the phase B. This is the actual investigation. This is one of the important phase in my side, in my own opinion, because you are now conducting the investigation. You are now investigating on um, your hypothesis on the problem itself. Okay. After your teacher panel approves your proposal, you can now start the experiment following the proposed procedure and begin collecting data. Okay. Your data could be qualitative or quantitative. It is recommended that you document your work using video or photograph. You can actually record it through a video or you take a picture. Okay. I have tried this also. It's really fun. No? Do not think that science investigator project is really sure it is really draining. But if you have it, you will be having fun with doing your SIP, then you will not find it hard for you. Okay? Since you're having fun and you're actually gathering more information, more data for your own good. That is for your own good. Right? Phase C. Okay. This is one of the important also part simply because you are now what? Putting your output in a report. Okay. The output is written report. Okay. The verb used there are in past tense simply because you're done conducting the exam or the experimentation. it follows the following format. Okay, there is a format to follow for output. Okay, one is the title page. It must be brief, simple, and attractive. This describes what your project is all about. Okay, I will let you see some of the outputs of my students in grade 7 before. Okay, abstract. It includes a summary of purpose, procedure, results, and conclusions of the investigatory or study. It is in single space with a maximum of 250 words in Times New Roman style, font 11, and fits to one page. The purpose of having this, the abstract in a one page, is for us to overview or to look into it, to have an overview of your research, of your science investigatory project. That's the purpose. Okay, this is the overview. Acknowledgement. It contains the acknowledgement of people or agencies that help you in the conduct of the investigation. Like for example, your parents or your relatives or the mayor or the barangay, if in case they're involved, okay, or your advisor, if in case they're involved. Okay. Table of contents. It gives you the list of contents of the written report with the corresponding page number. Okay, the page number of your science investigatory project. Okay. The fifth one is the introduction. Okay. It includes the background of the study, okay, which is actually in your rationale, which explains briefly why you choose the topic. Diba? In rationale, you're actually thinking about why did I choose this topic? What's with the topic? What's with the problem? Okay. Statement of the problem, which includes the general and specific objectives of the study, because you're not stating the problem, right? Okay. In the problem, you can actually see what are the objectives of the problem. Why do you want this topic? Okay. Significance of the study. This tells more important or importance of the study. What is the importance of having this study? Okay. Scope and limitation. This describes the coverage and extent of the study. In what content? What is the limitation of the study? Like in plant, I want to limit my study only in the movement of plant. Okay. I will not go beyond like the photosynthesis. Okay. It's beyond. I am just into um the movement of plants. So that's it. That's the scope and limitation. The sixth is the review of related literature, the one you have in your first phase. Okay, it includes the important prior studies of the topic. Diba you had already researched this one, and you have already gathered information to the net, and you actually check if it is correct. So this is now the review of related literature. The last one, I think this is the last, no, the seventh is the methodology. Okay. What is the method being used all throughout your study, or all throughout the science investigatory project? It specifies the materials, equipment, step-by-step procedure. Step 1, I heated the beaker with water. Step 2, and all of those. So those are in the methodology, in the methods of studying or the method of study. Results and discussion. Okay, it presents the findings summarized in tables, if in case, graphs, like for example, from day 1 to day 2, okay, day 2 to day 3, you're actually making a graph, a line graph, okay, or a bar graph, and pictures and the analysis of those findings. Okay, conclusion. It answers the question or questions or objectives based on the result. You will now generate answers to your questions based on the result. Okay. Recommendation. What can you recommend? Okay. It provides suggestion on the future actions or experiments to further verify or improve the result of your investigation. Okay. What can you recommend. Like for example, in the plant in the box, okay, I recommend not to put the plant in the box. Why? Because they cannot actually what? Cannot actually make their food, and they will eventually die. Okay, that's the
Wait,
recommendation.
why will they die? Why will they die?
They will die because they cannot produce their own food.
How? Exactly.
See, those are the questions. How? How can they produce their own food? Through the sunlight, through photons. What else? Presence of carbon dioxide, because there are two phases of photosynthesis: the light dependent reaction and the light independent reaction. So those are under recommendation. They cannot actually produce their food because there is no light. They need photon to break water to the process of hydrolysis. So these are just few. Okay. See, this is the beauty of having SIP. But I will try to make it more simpler. Let's have a way. Please let me know if how can we make an SIP which is not this long. So let's make it more shorter and precise. Diba? At least you can actually try doing the investigatory project. But this is really good if your group members are actually active, right, Travis? If they were just relying on you, well, there's no sense. Why should we have that one if in case your group members just rely on you? Correct? Okay. The last one, I think this is the last one, is the bibliography. Okay, this includes the references used in guiding the conduct of the experiment, like the websites. Okay, these are the few references, some books, okay, with the author. So you need to put it in under bibliography. Okay. The last, I think, the phase D, phase D is the oral defense. Okay, oral defense. You'll be asked with a panel of judges. Okay, you will be presented. You will be presented to a panel of judges who will ask questions about your project. Okay, this could be a teacher. This could be an outsider. This could be a an inventor. So your oral presentation is normally done using a PowerPoint presentation because you'll be including this one in a PowerPoint presentation. You're allotted 20 minutes outlining the problem, hypothesis, experiment, results, and conclusions. Remember, you're only allotted 20 minutes to do that. So if you have the summary, then it's okay. You will just read the summary and that's it. The phase E is the communication via poster presentation. Poster presentation means to say that you need to display your output. Display consists of 3 panels containing the abstract, okay, projectile, procedure, data, results, and conclusion. Okay. My students already done this one. Okay. As you can see, these are my students doing their SIP. They are actually grade 7. Okay. The one, the project there is the lemon battery. The lemon battery. They're actually creating a battery out of a lemon. They can because that
What's a
is
lemon
acid.
battery?
Hmm?
What's a lemon battery?
That's a
Yeah,
lemon
yes,
battery.
what's a lemon battery?
Okay, because of the acids in the lemon. So they tend to, if you're going to look at, there is an abstract procedure, okay, the projectile or title, the data, and the rests, okay, even documentation. Here, another one is the mouse trap, okay, and so on. So this is what we call as the display board. We have actually display boards here. I have that is actually mine. Okay. And supposed to be, you'll be doing that one. But I am still thinking on how can we maximize the class with the science investigatory project. Yeah, I want you to try this one. No? You need to try. This is really fun. Even my students are having fun doing the science investigatory project. We exhibited this one also. And we had gathered a lot of information. We had gathered a lot of idea. Right? Do you have any questions so far?
Yes.
Yes, Travis.
I
Go
was
on.
plugging a wire into a lemon. Like, how does it make that certain thing work?
Remember,
I'm confused.
you cannot directly plug an iron to a lemon and create a charge. Remember the cathode and the anode? They're actually creating cathodes and anodes there to create um charges, just like
Anode.
your wet cell. Remember your wet cell? In the battery, it has the battery has two types. You have the wet cell and the dry cell. Your battery in your remote control is a dry cell, okay? And your battery in your cars are wet cell, okay? They're actually creating wet cell. And when you do wet cell, you need to create a negative and a positive charge. The cathode and the anode, okay? Cathode is positive, anode is negative, okay? Yes, in potato also you can, but again, you need to establish a cathode and the anode in order for you to create a charge. Question, how can you create the cathode and the anode? That's the big question there. So in your investigation, you will actually look on how can you create a cathode and the anode out of a lemon or out of a potato. That's how. Okay. You will actually put it in your experimental procedure and look for alternatives and how you can do that one also. See, that's the beauty of SIP. Others think about, sure, it's so hard. No, it's not hard because you're just
It's
searching
interesting.
for answers, diba? You're just searching for answers, which um you had created a problem, okay? You had stated a problem, and you're just searching for answers to your problem, correct? Like for example, sure, how can they create a charge out of the lemon? That is actually a problem. That's a question. Okay, how? How do they do that one? That's a question. So you just research, okay? You look for an answer to your problem. That's SIP already, correct? Right. I think we had discussed a lot, okay? And I had prepared something for you in the LMS, okay? What I want you to do now is I want you to go to your LMS. Everybody, are you still with me? All
Yes.
right. How about Jairus, Levi, Jaden? Are you still with me? Sebastian, of course. Where's your camera, Sebastian? Arlie, Kurt, Travis. Okay. What I want you to do now is I want you to go to your LMS and do activity number 2. Let me stop my record. Let me stop my.
Concepting, and contrasting.
Yes. Okay, I want you to go to your LMS and answer activity number 2, which is comparing and contrasting. Okay. You're actually given 2 concepts there. Okay. 2 concepts. And in the concept, you need to create or you need to have their similarities. Okay. And compare the 2 concepts. Okay. We have 2 concepts in each number. So it is 5 points each. 2 concepts in each number. And you need to compare the two concepts, but you need to include their similarities. They are compared because they are similar. Okay? You need to include their similarities. Supposed to be in your module, it is comparing and contrasting using a Venn diagram, but you cannot use the Venn diagram there. Are you familiar with the Venn diagram? The circles?
Sounds familiar. Sounds familiar.
Yes. It looks like two circles, and then you need to put
Oh, it's like a ring that's like this.
yes. You need to put the details on each circles, and you include the similarities at the center. Since we cannot use the Venn diagram there, what I want you to do is I want you to compare and contrast the two concepts and include the similarities. What are their similarities? Right? Any questions so far? Question? How about Jairus? Hi, Jairus. All right. I think that'll go for today, class. Thank you for participation, grade 7. I really like your participation. No? And hopefully also, we can actually have an idea on how to proceed with our SIP. I think that'll go for today, class. Have a nice day, grade 7. I'll be waiting for your answers. Bye-bye. Take care. See you
Will we
soon.
pass it at Friday?
You can. You can
Okay.
because that's your independent learning. Bye-bye. Take care. Travis, bye-bye.